If R2 opens, what's the total current?
Okay, so if our there's two things that are not gonna change. If this were a physical circuit, there are the resistors and the total power. The resistors are physical components. So if R2 were to open, now we've just got a series circuit. So we add the resistances R1, 3, 4, 5, and 6. Just add them in series. Just add one to the next, and that's our total resistance. What are they asking for? Total resistance current. So then once the power supply is not going to change. It's either a battery or a generator. So you would take your new resistance and work it.
Volts divided by resistance.
Yep. And that would give you new current. If somebody wants to figure it. Someone get the new current that we can compare?
0.0035.
0.0035 amps. Or 3.5 milliamps. One of the questions, and I don't know how well we covered it, I know it was mentioned. It was on one of the quizzes or the test. It had mentioned if the resistance of a resistor went to 0. And if it's 0 resistance, it is a complete circuit. So if R4 were to go with 0 resistance, really it's as though it were a solid wire around it or through it. It would be 0. So then we would rework it as though it were 0. If it refers to an open circuit, then we have a break, and it's a break like that would create a series circuit down the right side.
You said if it had a 0 resistance, it'd be like
If it's
if
0
you
resistance,
took 3 and 4 and 5 completely out.
no. If 4 were 0 resistance, it would
R3
go
out of
from
5.
R3 to R5 with no resistance, so nothing would happen. It
Right.
would be as though I had just replaced it with a wire.
Okay.
We'll take a break here in a minute.
Quick question,
Yes.
on that schematic, if R2 opens, it's just a series circuit.
Down the right side.
So those values, 820, 680, and 1480 were calculated inversely. Do they still stay the same? Does
These
820
resistors are physical components, so they won't change. Once you've determined what their resistive
It stays
value
the
is, it'll be the same.
All right,
Now if you change, if R2 goes out of the circuit, you're gonna change the resistance. And if you change the resistance, you're gonna change the current. So a lot of numbers are gonna, a lot of this stuff's gonna change. But your resistors and your total voltage will remain the same. Let's do one more and then take a break.
Can we do the big H?
Yeah, you wanna do that H one?
Yeah.
It's got 5 resistors. Okay, so I'm going to redraw it right off the bat. I have 215 volts at the top. And then I have R1. And I'm gonna shift this over because that's the way we've been working, just to kind of, so you don't get lost in that being on the corner. And I'm gonna redraw 3 and 4, I think it is. Is it 3 and 4? 4 and 5. In parallel to each other. So looking at this, does that look more simple? I mean, right away I can see that these two I'm gonna add together, and then I just do 1 over x for the bottom section and add it to the top one. So I've got 240 ohms. I've got 150 ohms. I've got 200 ohms. And I've got 50 and 400. I could redraw these as one if I really wanted to keep it simpler, but I think you've got it already. These two are in series to each other, so the resistances will be added. So basically I have a fairly simple series parallel circuit. I got it. So what's my resistance on the bottom half? Anyone figure that yet?
72,
How much?
72,
72. And then I've got 240 above.
312.
I heard another number.
312.
312 is the total?
Yeah, that's
Okay. 312. So my resistance total is 312. So I'm going to go ahead and start. I can start filling these in. I'm going to do that. We'll try you. What I want you to do next is get currents for each of these legs and the total current. You can do total current right away because we've got 312 volts and 215.895.
.895. Is that correct?
I'm not using my calculator, but we'll find out in a
So
second.
it was volts, total volts.
689.
0.689? Does that answer your question?
I'm gonna double check that.
Same as R1.
Yeah.
So you're right. Thank you. Points R1, 0.689. So that gives me, I can determine my voltage on top for R1.
160.
165 on top?
Yeah, that's right. 165.
240 times 0.689. 165.36.
So if you look over here, I've got, how many voltage drops do I have?
1, 4, 2, 3.
I mean, for the total, I mean,
2 volts.
there's basically two, this upper half and my parallel section. So we've determined that 165 is up here at the top. I'll do it in black. 165 volts, and I have a total, I'm gonna draw a line of 215 volts. So what's my voltage drop for the parallel section?
50.
50 volts. So which resistors have 50 volt drops? 2 and 3. And then I didn't number them.
And then the other two have to add up to.
So 4 and 5 are going to add up to 50.
Yeah.
Okay, so now what I'd like to do, and the next step, is getting the current for 2, 3, 4, and 5. How are we going to do that?
Voltage divided by resistance.
Thank you. Voltage divided by resistance for 2.
0.3333.
And
And you get
0.3333 forever.
Yeah.
So R3s is
0.25.
0.25.
Yeah.
It's amps.
I think the last one's 0.406 for R4, R5.
Okay, so-
11.
You add R2 and R3, right?
So these, for this current, we're gonna use the 450 as the resistance to get the current,
Yeah,
right?
450 is gonna be the same.
50 divided by 450 is 0.111.
And that's gonna be for both of them, right?
Yep.
Cause they're in series.
Yep.
As a total, this leg has 0.111 amps, but these are in series to each other, so they see the same current. So I have all my currents. I can figure my voltage drop. So now with this current, I know the current and I have the resistance, I can get volts.
Sorry, could you go back to how you got 0.111? I know
Okay.
that those two add up equal to 0.25.
Do you know how we got these two currents?
Yes.
Okay, we got this one by adding those two together. You taking my word for it, or I want you to understand, these two are in series together, so we treat them as though they're one.
I understand that.
So we got the currents for each of these identically, all the way across. We just had to remember to use those two values combined. So now that I know the current for that last leg through 3 and 4, I should be able to figure my voltage. I've got resistance and I have current. So who's got voltages for 4 and 5?
5.55. 44.4.
44.5?
What was our voltage drop for 2? Okay, 45 point how much?
44.4.
44.4. Okay. And then the resistance we can figure just with the basic calculation.
But it's given.
They were, you're right, they were, I just didn't write it in. Thank you. So that one's not that hard, is it? That's pretty much your final for the lab.